What if you wrap a rope around the circumference of the Earth? Let's see what would happen. This is the Earth, and right at the blue line right here would be a rope that's wrapped around it. Now, let's say you cut this rope that's put around it, you separate the two ends of that, and you take 1 meter of rope, add it to this whole rope around the Earth, and then make the two knots. You would get a rope that's 1 meter bigger than the circumference of the Earth, and then take that rope and distribute it evenly around the Earth. You would get something like this. You also have to take a cat, not Schrodinger's cat, it's just a regular simple cat, a very nice cat. And the question is, does the cat fit under this rope? Intuitively, the answer is quite easy. It's a no. But let's see what the math has to say about it. If we take the radius of the Earth, we would have something like this. Let's call it R. And then we take the radius of the new rope, let's call it R prime. When we take the circumference of the Earth, we have the circumference is equal to 2 pi r. And r, that's quite important. Let's put it here. R is equal to 6,500 kilometers. That's a quite big radius. Now, intuitively, again, if you would put 1 meter in this 2 pi r, where r is 6,500 kilometer, 1 meter is not so much. So, again, intuitively, you would say it's quite a small distance that you would get. Well, surprisingly, we will prove that this is actually not the case. When you add 1 meter to the rope, what you get is the following. The new circumference, that's c prime, it's equal to the old c plus 1 meter. It's important to keep that the unit here will be in meters. And this is equal further to 2 pi r plus 1. But since we have an r prime here, that's the radius of the new circle, we would have this equal to 2 pi r prime. And we will take further this equation and try to manipulate it a little bit to see what we have. We take this further here and let's write it again. 2 pi r plus 1 equals 2 pi r prime. We can divide both sides by 2 pi and we get r plus 1 over 2 pi equals r prime. Now we take this r, we take it to the other side and we have r prime minus r equals 1 over 2 pi. And r prime minus r is exactly this distance right over here. This is r minus r, r prime minus r. And the distance here is 1 over 2 pi. And this is approximately equal to 0.16 meters, that is 16 centimeters. Now that's a bit of a surprise, and the surprise is not only that it's 16 centimeters, but that the actual distance here, which is 1 over 2 pi, means that our distance is not even dependent of the radius r. You have 16 centimeters of distance now, and that, well, take for an average cat, I think a cat does actually fit. Taking this again to the surprising part, we can see again that this is not dependent of r. That means whether this is the Earth that we're talking about and the radius is 6,500 kilometers, whether it is the Sun, which has a radius that is significantly higher, or you have a simple soccer ball that is quite this size, it doesn't even matter. You put a rope around it, you cut, you put 1 meter of additional rope, you distribute it evenly around the ball or the planet or the star, whatever you want, and you get 16 centimeters above the initial surface. And this is valid even if you take a point, which is an infinitely small sphere if you want, you wrap 1 meter of rope around it, well, take a guess, the radius will be 16 centimeters approximately from the point. That would make for a non-Schrodinger's cat that can pass or not pass under the rope. That's a definite pass under the rope. Until next time, have a good one. Don't forget to like and subscribe, comment if you'd like to see something interesting. Bye.